Version 3 is what I like to call the foundational design of Starship booster in the pad. That's going to give us the new capabilities we need to do the missions in front of us.
When SpaceX rolled Ship 39 out of the Star Factory and onto the test stand at Boca Chica, something looked immediately, unmistakably different. This was not a bigger version of the old Starship. This was a different machine entirely, taller, leaner, built from the ground up with one purpose: to make every other rocket on Earth obsolete overnight. The fully stacked version 3 Starship stands 408 feet tall. It is the largest, most powerful rocket ever assembled, and it is designed to be fully reusable. Every piece, the booster, the ship, everything comes back and flies again, at a projected cost of $2 million to $10 million per launch. For context, NASA's Space Launch System costs roughly $2 billion per launch and is entirely expendable. Every engine, every tank, gone. When NASA Administrator Jared Isaacman saw these numbers, he didn't defend the old way. He restructured the entire Artemis lunar program around Starship. Blue Origin scrambled to announce upgrades to a rocket that hasn't proven full reusability. So what exactly makes version 3 so different, and why has its rollout sent shockwaves through every corner of the aerospace industry? Let's break it all down. The rollout and what it revealed. Ship 39's assembly began deep inside the Star Factory at Starbase, Texas. Its liquid oxygen header tank was first spotted bearing a V3LOX cone label in March 2025. By August, the nose cone was stacked onto the payload section inside Megabay 2. The forward and aft flaps were installed in January 2026, and on February 26, 2026, Ship 39 rolled out. But here is where V3 immediately proved it was built differently. Previous Starship prototypes rolled straight to a basic cryogenic proofing stand. Ship 39 was routed to completely new test infrastructure at Massey's, a static fire stand fitted with a brand new truss structure specifically engineered to apply enormous physical loads to the ship's flaps and payload bay. That truss simulates the brutal forces the vehicle will endure when caught mid-air by the chopstick arms of the Mechazilla Tower. This is not theoretical testing. This is catch rehearsal under real mechanical stress. The pressure testing campaign moved fast. Ambient testing completed February 28th. Partial cryogenic proofing followed immediately, running through March 1st. Full cryo loading, where the tanks are filled with superchilled liquid nitrogen to simulate actual flight conditions, was successfully executed between March 2nd and March 4th. Ship 39 held. No cracks. No structural failures. The redesigned hull and propellant system passed every test that had destroyed earlier prototypes. Meanwhile, the V3 Super Heavy booster, designated Booster 19, was running its own aggressive campaign. SpaceX assembled Booster 19's primary barrel structure in just 25 days. That is half the time it took to build the final version 1 booster. And on March 16, 2026, Booster 19 fired 10 of its brand new Raptor 3 engines on Pad 2 at Starbase. It was the first ever static fire of a V3 vehicle. And it was the first operational test on SpaceX's second launch site. All 10 engines ignited successfully. The engineering leap. What makes V3 different? Photographers and aerospace analysts tracking the rollout immediately noticed fundamental differences from every previous Starship. These are not cosmetic changes. They represent a complete architectural rethink optimized for operational reusability at industrial scale. Start with the grid fins. Previous Super Heavy boosters used 4 grid fins to steer back through the atmosphere during hypersonic descent. Version 3 uses only 3. But those 3 fins are 50% larger than the ones they replaced, with reinforced internal mechanisms designed for the deceleration forces of a tower catch. Fewer fins, bigger fins, stronger fins. Every decision driven by performance data from 11 previous flights. The structural catch pins have been relocated from the payload bay to near the nose cone. This repositioning changes the load dynamics during catch and stacking, distributing forces more evenly and allowing for heavier payloads without structural compromise. High-resolution images of Ship 39's payload bay revealed active docking arms and adapters. These are the hardware required for in-space propellant transfer between 2 starships in orbit. That capability is mandatory for lunar and Martian missions where a single starship cannot carry enough fuel to reach the moon and return. V3 is not a test vehicle. It is built for the actual mission architecture and the heat shield. Ship 39 rolled out with a fully tiled, pristine thermal protection system. SpaceX's Cape Canaveral facility currently produces 1,000 heat shield tiles per day, with capacity to scale to 7,000 per day. That production rate is calibrated to sustain a target cadence of 10 Starship flights per month. not per year, per month. Raptor 3, the engine that changes everything. But the single most important upgrade driving the entire V3 leap is the engine, the Raptor 3. A single sea-level Raptor 3 produces 280 tons of thrust. That is a 21% increase over Raptor 2 and a 51% increase over the original Raptor 1. Elon Musk has stated that ongoing tweaks aim to push this to 300 tons per engine. At 300 tons across 33 engines, the Super Heavy booster would produce 10,000 tons of combined thrust at liftoff. More than double the thrust of the Saturn V, the most powerful rocket ever built before Starship. And here is what makes engineers at competing companies lose sleep. SpaceX did not just make the engine more powerful, they made it lighter. Raptor 3 weighs 1,525 kilograms. The original weighed 2,080. That is over 500 kilograms saved per engine. Across 33 engines on the booster, that translates to more than 16 metric tons of dry mass savings. 16 tons that convert directly into additional payload to orbit. The thrust-to-weight ratio reached 183.6. The original Raptor managed 89. This is not incremental. This is generational. And perhaps the most visually striking change is what is missing. Raptor 3 has no external heat shield. Previous versions required bulky shielding to survive atmospheric re-entry and the radiant heat of tightly clustered engines. SpaceX eliminated it entirely by integrating regenerative cooling channels directly into the exposed components and internalizing all critical plumbing. As Gwynne Shotwell described it, the resulting engine is truly a work of art. It operates at 330 bar of chamber pressure, 4,800 pounds per square inch, the highest of any operational rocket engine in history. Why NASA and Blue Origin are scrambling. To understand the shockwave, you need to see the numbers that NASA and Blue Origin are staring at. NASA's SLS lifts 95 tons to low Earth orbit in its current configuration. The future Block 2 aims for 46 tons to deep space, but SLS is entirely expendable. Every launch requires building a new vehicle from scratch. Estimated cost, $2 billion per flight, and NASA has never launched more than one SLS in a single year. Starship V3, fully reusable, delivers 100 to 200 tons to LEO. In expendable mode, 300 tons. Target cost, $2 to $10 million. The market has already priced this in. Voyager Space contracted a Starship launch for the Starlab space station at just $90 million. A payload capacity rivaling the Saturn V for roughly 4.5% of an SLS launch cost. NASA Administrator Jared Isaacman's response was sweeping. He publicly stated legacy programs are over budget and behind schedule. He shifted Artemis 3 from a lunar landing to a LEO docking test in 2027, pushing the actual moon landing to Artemis 4 in 2028. His philosophy: vehicles over contracts. Focus on hardware that actually flies, not cost-plus arrangements enriching incumbents while delivering delayed results. And Blue Origin. New Glenn successfully reached orbit and landed its booster in November 2025, launching NASA's Escapade Mars mission. That is a genuine achievement. New Glenn lifts about 45 tons to LEO at $68 to $110 million. But Blue Origin's immediate response to V3 was revealing. They announced a Super Heavy 9x4 variant targeting over 70 tons to LEO. Impressive. But 70 tons is still entirely dwarfed by Starship V3's 200-ton capability. Blue Origin is chasing a target that keeps accelerating away. 11 flights that built, V3. Version 3 exists because SpaceX treated every previous flight, including the spectacular failures, as tuition toward the final design. Flight 1 in April 2023 was a catastrophe. Multiple engine failures, uncontrolled spin, vehicle destroyed. But that explosion proved the absolute necessity of a water deluge system. Flight 2 proved hot staging works. Flight 3 got the ship to space and conducted the first propellant transfer demo. Flight 4 was the turning point. Despite losing an engine at liftoff and severe flap damage during re-entry, both vehicles survived and splashed down under control. Flight 5 in October 2024 was historic. The Super Heavy booster returned to the launch site and was caught mid-air by the Mechazilla tower arms. First time in the history of aerospace engineering that a booster of that size had been caught by a tower. Flights 6 through 11 pushed the Block 2 vehicles through iterative refinement. Some succeeded, some failed. Flight 8 lost the ship, but caught the booster even after 2 engines failed to relight. Flight 9 attempted the first ever booster reuse. Flight 10 recovered from multiple anomalies to achieve a successful splashdown. Flight 11, the final Block 2 mission, closed the chapter clean. 11 flights in 2.5 years. Fly, break, fix, fly again. Faster than anyone thought possible. What comes next? Flight 12 is targeting late April 2026. It will be the first ever V3 flight. The objectives are ambitious. Validate the lengthened hull under maximum dynamic pressure. Test Raptor 3 engines under actual flight conditions. Continue advancing ship-to-ship propellant transfer. The manufacturing pipeline behind it is relentless. Booster 20 and Ship 40 are already being assembled for Flight 13. SpaceX is constructing massive gigabays at Starbase and in Florida, capable of housing 24 workstations simultaneously and building the even larger boosters planned for the future Block 4 architecture. The FAA currently authorizes 25 Starship operations per year from Boca Chica. Up to 44 more from Kennedy Space Center are pending final approval. Total target across all sites, 146 Starship flights annually. And the financial exclamation point. SpaceX is reportedly preparing an IPO as early as June 2026. Dubbed Project Apex, the offering aims to raise $75 billion at a valuation of $1.75 trillion. Analysts point directly to Starship V3 as the core driver of that astronomical number. Philip Johnston, CEO of StarCloud, put it starkly. He said, "We are really talking about 1,000 times more tonnage per year that we can get to space. The launch cost might come down by between 10 and 100 times. This is not just a rocket. It is the foundation of a vertically integrated space economy."